This is the second part of chapter 11. We're now going to do a simulation where we're not given percentages, but we're modeling a situation that has actual objects instead. So we're still doing the same steps as we did yesterday. We're going to decide single or double digit, assigning numbers to outcomes, when do we stop looking at numbers, what we should be keeping track of. Maybe today, because we are dealing with actual objects, we might need to skip some numbers, and then we finally need a conclusion. So here is today's question. That's the second part of chapter 11 with simulations. So Lucky Charms advertises that you get a ballpoint pen with every box of cereal you buy. There are 6 different colored pens. Okay, so there's my number of actual objects, 6 colored pens. How many boxes of cereal would you expect to buy on average to get the complete set of pens if the chances of getting each of the pens are the same? Okay, so if there's 6 pens, I'm going to go ahead and use single digits because I only need 6 numbers. So I'm going to write that a single digit equals 1 pen. It says that there's 6 different colors of pens, so I'm going to need 6 numbers. So if you want to start counting at 0, that's cool. If you want to start counting at 1, that's cool. I'm going to just count from 1. So 1 equals 2. So this is like pen number 1, pen color 1, pen color 2. Okay, this is kind of tedious, so I'm just going to go ahead and put little parentheses here. 3, 4, 5, and 6. Okay, so there's my, I've said that I need to use single digits, and I'm going to be using, I'm going to be using the numbers 1 through 6 because that's how many pen colors are in the problem. This means when I come up on a 7 or an 8 or a 9 or a 0, they don't matter for this problem. So we're giving directions to people is how I like to think about this. So 7, 8, 9, or 0 is going to be just skip over or ignore. They don't mean anything for this problem. Since we're modeling real pens, there's 6 real pens, those numbers don't count. Then I need to say, when do I stop looking at numbers? So according to this problem, it says, how many boxes do you expect to buy to get the complete set? So I'm going to stop, I'm going to write it over here. I'm going to stop after I get each of the numbers 1 through 6. So that would be a complete set of pen. So stop after I get each of the numbers 1 through 6. What do I want to keep track of? So according to this problem, how many boxes of cereal would you expect to buy to get the complete set? So I want to count total boxes of cereal or total pens that I needed to get all 6, 1 of each color. So count, I'm just going to write count total boxes of cereal. All right. And so here's the thing today. So when it says when dealing with actual objects, we might need to skip some. So let's see if that pertains to this problem. So I'm getting a box of cereal. If I get a 3, okay, that means I've got pen color 3. If I get a 3 again, in this case, it just means that I've bought a box of cereal that has pen color 3. So in this situation, it's okay to get repeated numbers. It just means I have multiple colors of that pen. All right, so I don't need to skip anything that's been repeated. Okay, so I've got what numbers I need to look at, what they all represent, ignore some, when do I stop, what do I keep track of? It's time to just try the trials. So I'm going to use this random number table, the same one I used yesterday, but I'm going to jump down to row 5 because I can see that pretty well. So let's try to move all this. All right, so, whoa. All right, so row 5 here. I've got a 4, so I need to somehow keep track of what's going on. Here, scratch paper. Oh, but we can't see the scratch paper. Welcome to my day. Let's go this way. Okay, so here's my row of numbers. Okay, so, wow. All right, well, I got the 4. 7 I'm skipping. I have a 3. There's a 5. There's a 2. Hey, I'm only missing 1 and 6. Okay, that's nice. Another 4. So I'm just going to put maybe like a box. It's another pen, but it's not the one I needed. There's a 2, so I didn't need that one. 8, I'm just going to ignore. 5, it's a repeat of that color. 3 is a repeat. Let's see, keep on going here. 9 doesn't matter. Oh, and you want to know what? I've lost track. 4, 7, 3, 5, 2. Okay, then we had the repeat, the skip, the repeat, the next repeat. That's where I got messed up. Okay, another 4 repeated, a 2 repeated. There's the 9 that I skipped. Okay, the 0 is a repeat. Or 0 doesn't matter, excuse me. Wow, see how this can be confusing? Okay, the 3 is a repeat. The 9, there's the 9 that we're skipping. The 7 is a skip. The 5, we've already got. The 0, we don't need. It's a skip, okay, or an ignore. The 4, we've already got. Okay, where's the 1s and the 6s? Are you kidding me? All right, well, here's a 5. We've already got the 5. The 6. Oh, finally a 6. Yes. Okay, then immediately we get a repeated 6. We get a repeat 5. We get another repeat 5. We get a 7 that we're ignoring. There's a 0 that we're ignoring. There's a repeated 3. There's a repeated 5. A repeated 5. Wow. Where is the 1? All right, there's an 8 we're skipping. An 8 we're skipping. A 6. That's a repeat. 0 that we're skipping. Another 6. Lots of 6s now. Here's another 6. And finally a 1. My goodness. Okay, well, I can stop now because I've gotten all pens. 1, 2, 3, 4, 5, and 6. So I have all 6 colors. You can keep track however you want. Maybe there was a better way to do this. Okay, and then the last step for this particular trial is to keep track. Now count these total amount of boxes of cereal I had to buy for the complete set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wow, 25 boxes of cereal for the complete set. So I'm going to go back over here and just write down that trial 1, it was, gosh, I hope 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 20. Oh, only 25. Wow, yay for recounting. Okay, 25 boxes of cereal. Okay. Wow. I'm thinking of doing another trial. Why not? Let's do one more. Sure. Okay, so I ended right here. So that's where I ended. All right, maybe I can keep track better this time. I don't know how, but we'll try. So I've got a 4. I have a 0 I don't need. I have a 6. I have a 3. Woohoo! I don't need the 8. I don't need the 7. Here's a 5. All right. I've already got 4 of my numbers again. Okay, I don't need the 7. I don't need the 7. No 0. 6 is a repeat. 5 is a repeat. 7 I don't need. Now I'm jumping down to the next line. It looks like I need a 1 and a 2. Let's hope they come up soon. Hey, I got a 2. Yay. Okay, zeros don't count. Zeros don't count. 6 I've already got. 4 I've already got. 0 doesn't count. 4 I've already got. 2 I've already got. 6 and 6. The one number that I'm looking for yet again is a 1. Okay, 7 I don't need. 4 is a repeat. 0 I don't need. Hey, there's the 1. Yes. Okay, so how many pins did I actually look at? I don't want to count the numbers that I'm ignoring. So let's see, it took 1, 2, 3, 4, 5, 6 were duplicates. 6. There's 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so that was not as many. So I'm just going to add that. Trial number 2 was 15 boxes. So let's just take those two trials in the interest of time here. So on average, 20, 30, so 40 boxes divided by 2 trials. On average, I needed 20 boxes of cereal to get all 6 colors. All right, that is what we're going to be doing, this type of problem, modeling real objects, second part of chapter 11. Yay!